Well, hello Internet, and welcome to my F# video tutorial. In this one tutorial, you are going to learn the core syntax of the F# language, and in the description underneath this video, I have a link to all the code as well as a transcript of the video. And also, I have timestamps to all the individual topics covered in this video, so you don't have to watch everything all at once. You can watch part and then come back to it and just click on a timestamp and go back to where you started. And like always, I have a lot to do, so let's get into it. Okay, so here we are. This is Visual Studio 2017, the brand new Visual Studio. And what we're going to do here first is we're going to come in and we're going to go File, and we're going to come down here and go New Project. And then inside of this, you are going to open up other languages, Visual F#, and then Console Application. Give it a name, and then come down here and click on OK. I went and called my project F#tut, as you can see right there, and it automatically created program.fs, and that's where we're going to be writing all our code. And you can also see program.fs over here. Okay, so let's just start it here. Now, basically, F# is Microsoft's functional language, and it's going to provide a way to develop predictable code that is often way shorter. And that's a major benefit of functional languages, in that they apply functions to data rather than focus on state changes like most object-oriented languages. And another benefit of functional languages is that they are great in regards to executing multiple processes at once. And one of the reasons why is because variables for the most part are immutable, meaning that once the value is assigned, it cannot be changed. So, but we'll get into all that. What we want to do here, very first thing, is we want to open up Open and System. And what this is going to allow us to do is access things like read line and write line, different functions that are available in C# that we may want to use, and a couple other functions as we go on. We're going to be doing a lot of stuff here. Now, I'm going to do a rundown of how to both read information in from users as well as how to output it, and a little bit about variables. Now, if you want to create a function, it's very simple. You just come in here and create the function like that. There it is. And you go equals, and then you tab in and you are going to start writing your function. Now, white space is going to be used to define your code block, so it's very important to go and make sure everything's tabbed in exactly the same. And let's say that we would want to come in here and print to the screen and not use a new line. What we would do is go print F, and that's the version of print to the screen without a new line. And I'm going to say something like enter your name, and put this like that. And another thing we're going to want to do is come way outside of this function, and basically to get out of the function, you just go and get rid of the white space there. And we're going to type in system.console. Actually, you don't have to type system. This is a reference to this guy, open system. So you're just going to be able to go console.read key, and that's going to read in an individual press on the keyboard. And then it's just going to say ignore. It's going to ignore that input from the user. And basically we are using this to keep our console window open until the user clicks on a key on the keyboard, and then it'll close. So that's the whole purpose of that. And if you want to be able to call this function, you just come in here and go hello outside of the function itself, and there you go. Basically, this is a hello world application, but we're going to do a little bit more with it. Let's say we want to read data in from our user. We're going to go let, and basically what let does, if I didn't say before, is it's going to bind a name to either a value or a function. So hello, or in this situation, I'm going to create a variable called name, and I'm going to use read line to read in input from our user. And as you can see, there's no semicolons, none of that stuff at the end of these statements. Now, print fn, on the other hand, is going to put a new line after it prints something on the screen. And another thing that is important to know about printfn is that it is statically typed in regards to parameters that it is going to receive. And what I mean by that is, for example, you're going to do something like a %sign and s, and that's going to represent a string. So, and well, let's do an example and then I'll explain it. So let's say they go and they enter in their name and you want to go hello and answer with whatever name they put inside of there. That's how you do it, okay? And we know that this is a string here, and the other different types you're going to have is you're going to have integers, and you are going to have floats, and you're going to have booleans, and you're going to have, well, strings, obviously. I already covered that. You're going to have uppercase A, which is going to represent an internal representation of things like tuples. Don't worry about that if it's confusing. As time goes by here, we're going to give lots and lots of examples, or an O, which is going to represent an object. So let's come in here and let's go and actually execute this. You can see your first F# application execute. We're just going to come up here, click on Start, and it's going to automatically start itself. As you can see, it comes up here, says enter your name, and I'm going to type in Derek. If I can spell my own name properly, hit enter, and it goes hello Derek. Okay, so very, very simple. And I'm just going to hit any key, and it's going to close the console, and that's what this guy does down here. Now I'm going to do something a little bit more complicated. Let's go and get rid of all of this here because it's sort of getting in the way. What I want to do now is show you an example of how we can format a floating point numbers. So let's come in and we'll see some of the maximums and minimums and things like that. So let's say we have pi and we want to output that on a screen. Well, let's just throw a float inside of there, and then we'll just throw pi inside of there like that. Now the whole reason I did this is just to show you the precision of working with floats. You can see right there by default it is only precise up to 6 digits. Okay, and another thing, if let's say that 6 digits is actually too much for you, you'd actually like it cut down to 4 digits. You just put a period in there and a 4 and you run it, and it's going to automatically cut it down to 4. But let's say you actually want to get more precision. What we can do here is we can get more precision. We can get a maximum of 27 decimals of precision. And to do so, you go something like big and pi is equal to, and throw in 27 digits, and then end that with a big M. That is going to get you the precision that you are shooting for. So let's just change this to big pi. And then what we're going to do is inside of here, instead of F, you're going to put an M. And then, of course, we're going to throw big pi inside of there. So there's big pi, and there it is, and run it. Whoops, there was an error. What did I do wrong? Oh, I have a little space there. And by the way, all of your variable names are going to start off with underscores or letters, and then thereafter can contain numbers. So let's save that now. Everything's wonderful, and let's run it. And you can see now that it was able to output many, many, many more digits whenever you put the M inside of there. So that's important to know. You're also going to be able to add padding to both the right and the left with printfn. So let's come in, let's just get rid of that. And we'll do something like, oh, I'm just going to show you how padding works. So let's get rid of all that, and let's change this into % and -5s, and then % and 5s. And what this is going to do is add padding to both the right and the left of whatever we have inside of there. You're also going to be able to come in here and have multiple different parameters passed inside, and you don't have to separate them with commas or anything, just like this. And we can run that, and you can see here that we have padding here on the right, and then padding here on the left side. So right padding, left padding. That's how that works out. Another thing that's interesting is you can actually have dynamic padding, and I'll show you an example of that. You can just put a star inside of there and then come out of here and then define how much padding you want and then what you actually want in there in regards to your string. And we'll throw that in there and and you can see it added padding to the left side for our string high. Okay, so there is just a bunch of useful information in regards to input and output and working with print as well as, or printf as well as printfn. And now I want to do a couple more examples of binding. Okay, so I'm going to change this guy up here to bind stuff, and then I'll come down here. I'm going to do more with functions as the tutorial continues. So bind stuff like that, and then inside of here, basically your default variables, like I said before, are going to be immutable, and that is unless they are actually marked mutable. So I'm going to give you an example of that. So you can actually use mutable variables inside of here, but it's not very common with most functional languages. You just put mutable inside of there, and just like we did before, we go equal to, and 175. And since you have mutable inside of there, you're going to be able to change that value. How you change it is with this little sort of arrow symbol. And now all of a sudden I weigh 170. And just to show you that that actually worked the way that I am saying it's working, we can go inside here and go weight. And remember, this is an integer, and weight like that. And while we do another example here as well, you're also going to be able to come in and use what are called reference cells if you want to change a value. So you can do something like let change me and equal to and reference and 10. And in that situation, you'd be able to come in and go change me and then colon equal to and 50. And let's go and actually show you that that works also. So let's come in there like that. And we'll just call this change or something, and that's okay. And we'll change this to change me, and there it is. Whenever you want to get the value of that reference though, you're gonna have to come in here and put an exclamation mark like that. Just little weird things you have to do. Let me tell you, you're not going to be doing this much because, like I said, with functional languages, you're mainly going to want to work with immutable data. But either way, I just wanted to show it to you just so you can see what it's like. And we can come in here and run it just to prove that, yes, in fact, I am able to change those values. Okay, so a couple examples of some crazy stuff you can do binding-wise with F#. And now let's jump in, and since this is a functional language, maybe we should talk about some functions. Okay, so I went and changed the function we're working here to dofuncs, and then I'm calling dofuncs down here. And if I'm going too fast, just liberally use that pause button as you're watching these videos because I go pretty quick. Okay, so let's go in here. We can create functions inside of functions, of course. So let's call one getSum. And basically, functions are going to start with let, of course, like you saw. Then you're going to have a name, and then you're going to have parameters. So we'll go x. You're going to then have optional parameter types. So you go x and a colon and int like that, comma, and integer type for the next parameter. And then you're going to have an optional return type. And then we'll say x plus y. And there you just defined a function. And now we can come in and we can execute that. So we can say 5 plus 7 is equal to, and that's going to be an integer. And then to call this function, I'm going to go get sum, and 5 and 7 are going to be the parameters we pass inside of there. And there we go. And we can run that. We're going to do more interesting things with functions, but you can see right there the function worked. Okay, so we got a value of 12. And since you are watching a F# tutorial, I'm guessing you probably know what a recursive function is. So let's come in here and demonstrate one. Okay, so to make a recursive function, which is a function that calls itself, you're going to go let rec like that. And I'm going to have this guy calculate a factorial. If you don't know what that is, I'm going to show you an example. I'll walk you through it. And let's go and do a brief explanation of how if statements work, as well as else statements. So they work just like every other language. We're going to say here, if x is less than 1, then we want to return a value of 1. Else, if x, otherwise, or else, we're going to go and get the value of x and multiply it times factorial, and we'll pass in x minus 1. Like I said, if this doesn't make sense, don't worry about it. I'm going to explain it step by step here in 1 second. So let's go and get the factorial, for example, of 4, and this is going to be an integer. And then we'll come in here and we will go and call our factorial function right like this, and then we'll be able to execute it, and then I'll explain exactly how it works. So let's go up here, click on start, and you're going to see the factorial comes back of 4 is going to be equal to 24. Now, how do we figure that out? Well, here you go. This is everything you need to know. So the first time through our loop, like I said, recursive functions call themselves. So we come in here and we have a value of 4. Comes down here, it says if 4 is less than 1, which it is not, we're going to return a value of 1, which we can't because it's greater than 1. In that situation, we're going to come down here and we're going to go 4 times, call the factorial function with 4 minus 1, and you get exactly what you see here. 4, and then call the factorial function again, which is going to pass in a value of 3. Then we're going to go up here, factorial, 3's comes in, 3 times factorial, of 3 minus 1, which is going to be equal to 2. See exactly how that works. Then we're going to come in again. Now we have a value of 2, and we will pass 2 inside of here. Then we'll have 2 times factorial of 2 minus 1, which is going to be equal to 1. Come down here, 2 times factorial of 1. What happens whenever we pass a 1 in? If x is less than 1, then 1. Okay, so in that situation, we are going to come in here and get our value of 1, which is going to be this guy right here. So 2 times 1 is equal to 2. This value right here is going to be returned up inside of here because of this function right there. Then we'll get a value of 6. That 6 comes up here. We multiply that times 4 and get our final answer of 24. Okay, so if you don't completely understand, it's okay. Just an example of a recursive function. We're going to do a lot more with functions, and we're going to do a lot more with functions right now. Something else that is really cool is we are going to be able to use lambda expressions. So let's create a list inside of here. So we'll just go random list, and I'm going to go into detail with things like if and else and creating lists and working with lists as the tutorial continues, but I'm just moving along here. So 2 and 3. So there you go. You created a list with 1, 2, and 3 inside of it. Now what we're going to be able to do is use a function called map, which is going to allow us to perform a calculation on every item in the list and then return a brand new list. So to do that, let's go and go random list 2 is equal to, and the map function's located in the list module. So we're going to go list map, and then you're going to use fun inside of here. And basically fun's going to be used to create lambda expressions. So we're going to say fun x. This is a function that's going to receive a value of x. And for each value of x, it is going to multiply those values by 2. It is going to receive input of random list, and it's just going to go through random list, value 1, multiply it times 2, and add that to the random list too, so forth and so on. So let's go in here and let's go and see what that actually looks like. So I'm going to go print fn, and let's just call this double list. And like I said before, you're going to use a % and a to get a internal representation of this new list, because this is an easy way of figuring out what's actually in the list. So we'll go random 2, exactly like that, and we will run it, and you're going to see it doubled every single value inside of our list. Later on, I'm going to show you how to cycle through all of these different items and output the list items one by one. But I just wanted to show you that example because I think it's interesting. Another thing we can do is we can use the pipeline operator to nest function calls. So in this situation, what I'm going to do is I'm going to create a list. I'm just going to create it right here. So 6, 7, and 8, exactly like that. And then on the next line, I'm going to come down and put a pipe symbol in there. It's on the right side of your keyboard if you don't know where that is. And then that little bracket. And I'm going to use filter. And what filter is going to do is it's going to keep only items in the list that match a condition. So I'm going to say list.filter, and then inside here define my function. So I'm going to go fun, and this is like an anonymous function, what we're defining here. So this is going to receive a variable that I'm going to have be v, and I'm going to go and take the modulus of this, and what modulus does is it does a division, and it returns the remainder of said division. And then I'm going to check if the value returned is equal to 0. So what I'm trying to do here is create a list of items that are even, or even numbers. So then what I have to do after this is go and put the pipe and the bracket there, and I'm going to go list dot map, and then I'm going to multiply every item in the list that filter went through. So filter is going to get rid of things. It's going to say, hey, if this is not an even number, I don't want it in my brand new list. And then what map's going to do is map is going to take all these items and it is going to perform some operation on them. In this situation, I'm going to get every even number and multiply them times 2. Okay, so we got that all set up. Whoops, this is not proper. I have to come in here and go fun like that. Okay, so now we have it all set up. And then the final operation that I want to perform on this list that I have up here is to print everything. And how I can do that is just go print and fn exactly like that, and say that I want to print out my list of even doubles. So you can see it's taking the list, it's going, pumping it through the filter, then it's pumping it through the map, and then it's going to pump it down here and print it out on the screen. We're going to go at, or the % and A, and this is a very neat way of working with this stuff. And you can see right there, got only the even numbers and multiplied only the even numbers times 2 and printed them out on the screen. So this is just the tip of the iceberg of ridiculously cool things we can do. Another thing we can do is we can come in here and execute multiple functions. So let's say we go mult num, and this is going to be, it's going to be a function that's going to receive one value, and it's going to multiply that one value times 3. Okay, so we created a brand new function called multiply number, and then let's copy this and let's make another one. So let's throw this inside of there, and we'll call this add number. So add number like this, and this guy is going to receive y, and it is going to add 5 to that. So I'm going to say plus 5. Now what we're going to be able to do is actually perform that operation on multiple, in multiple different ways. So what we're going to be able to do is go let, and let's say we want to be able to receive a value that is going to multiply the value times 3, and then we want to call this one and add 5 to it. We can actually do crazy stuff like that. How we can do it is we can go mult num. So we're saying we want to multiply the times 3, whatever value we get inside of here, and then we want to add. So like just exactly like that. So let's go and copy this. We can also do it in the opposite direction. So we're going to be able to come in here and go add and then mult. So multiply. And in this situation, we don't even need to change anything around. We just need to change this guy. So there we are. So in this situation, it's going to multiply and then add. And in this situation, it's going to add and then multiply. So there's all these cool operators inside of F#. So let's show you an example of exactly how those are going to work. So we'll just go mult and add, and this is going to be an integer that we're working with here, and to actually call the operation on a number for both of those operations. So you pass a 10 inside of here, and then let's copy this, and then we'll have it be just slightly changed. We'll change this to add and then multiply, keep the value the same, and then this is going to be add and then multiply. And we'll save that and we will run it, and you can see all of the really cool things we can do with F#. Okay, so neat stuff. And of course, we're going to be doing more things with functions as the tutorial continues, but I noticed that I was talking about modulus and all these other weird things, so why don't I take a brief step back and show you some math functions. Okay, so we're back inside of do math now. Change the name there. You don't need to change the name every time like I do. And here's a rundown of some basic mathematical functions. Of course, we can add values together. You can see how that's done. Subtract, multiply, divide. This is the modulus, which is going to return a remainder of a division. And one thing that's important to know is if you want to put % signs inside of print fn like that, you're going to have to double them up, and this is going to show up as 1% sign, okay? And then here you have 5 to the power of 2, and we can run that just to see how all of those guys work out, and you can see exactly how they all work out. And of course, if you forgot and you wanted to have this guy only be 2 decimal places or something else, 1 decimal place, whatever, you can go and put a point and a 1 or a 2 or a 10 or whatever you want to put inside of there. Okay, so neat stuff. Now let's go and let's say you wanted to get the data type of a variable. Let's go and go let number, and let's assign a value of 2 to it, and let's go and figure out what the data type is. I know you know, but you know, I'm just showing you a way of figuring it out. So you're going to put a % sign and an A inside of there, and then you're going to go number and get type, and that is going to give you the data type. And while we are at it, let's also cast to another type inside of here. So let's just copy this guy right here, throw that inside of there. And what we want to do is we're going to go a float like this, and we're going to change this to point to float. And to change to a different data type, all you have to do is put in the data type you want to switch to. So we'll go float and number. And now that is going to be a float just by putting the float inside of there. And you can do the same thing with booleans and all the other different things. So in this situation, we'll go this would be an int. So integer, which is, there we are. And we'll just change this to I like that. And of course, it's going to knock off the decimal places. And then we'll change this to int. and then we'll go and put something like 3.14 inside of there, just so you can see an example of how those are going to work. So that's how we get the type and how we cast. And you can see exactly right there that they worked beautifully. Now there are a bunch of other different built-in math functions. Here's just a rundown of a whole bunch of them. Of course, you have cosine and sine and tangent and all those guys. This is going to give you an absolute value. This is going to round for ceiling, so it's going to round whatever the value is that you give it up. Floor is going to round down. This is a log function. This is a base 10 log function, and there's square root, and there's a couple other ones. Just wanted to cover all of the basics though really quick, and you can see exactly how all of those different math functions will work for you. All right, so there is a rundown of a lot of the math that you're going to use with F#. And now what I want to do is come over and do a lot with strings. So I'm going to call this string stuff, and we'll come down here, and of course we will call string stuff. So string and stuff, and you've seen some strings already. You're getting acquainted with them. One thing that's important to know is inside of your strings, there are certain escape characters. Like for example, you have a new line, and then if you want to actually put in a backslash, you have to put in 2 of them, and then you can do double quotes like that, and single quotes, and you actually already saw what happens if you want to put in a % sign. So there's some escape options for you. Let's create a function. Let's just keep it very simple. Let's call this string1, and I'm going to say something like, this is a random string. And there you are. You just created a string. And another type of string you can have is what's called a verbatim string. And these are going to be strings that are going to ignore backslashes. So all the things that I just showed you before. Create one of them. You just put an @ sign like that. And on here I'm going to say, I ignore backslashes, and you can go in there and throw some backslashes in there just to make sure that that works, but I know it does. Another thing, let's say you wanted to have, or well, here's another thing called triple quoted strings. So it's just another option for you, and it would allow you to use quotes inside of your strings. So you just put 3, double quotes inside of there, and then you could say something like, I ignore double quotes and backslashes. So there's another thing. And then you could put that in quotes, and then 1, 2, 3, and there you go. So that's another option for you. Of course, we're going to be able to combine strings. So let's go and create another string here. So we can go string1, and let's throw a space inside of there between the 2 strings, and then plus and string2. There you go. We can come in and get the length. Let's just go and print the length out. So we'll go print fn, and we'll go length, and that's going to be an integer, of course. And to get the string length, you type in string followed by length. And let's go and get the length of string 4. Print that out there on the screen. You're also going to be able to access values or characters by index. So let's go and do that. So print fn, and here I'm just going to put, this is the character code. So it's just going to be a %. There it is. And if you want to go and, let's say, use string1 and get whatever's in the 1 index, that's how you do that. You're also going to be able to get a substring by passing in a range, and we're going to be doing more with ranges as the tutorial continues. Let's go first word, for example, and %. This is going to be a string, of course, and to get that guy, we're going to say that we want to, well, you're going to put a dot, and then you're going to say we want to start at index 0, and then we want to go up through index 3. So there that is, and there that is. So neat stuff. And let's execute that so you can see how all those different guys are going to work for you. See the length there is 44. You're going to see here H right there. We went and said we wanted to get the first index of this guy. Well, there's the H, and we grabbed the first word. 0, 1, 2, 3. Okay, and that is the range. 0, 1, 2, 3. Okay, so that's a range function that's available. Another thing is we are going to be able to use collect to execute a function on each character inside of a string. So let's say we want to have every single character inside of our string be uppercase. We can go string and collect, and then fun and C and S printf, and put in our character inside of there, and let's put a comma there with a space, and then the individual characters. So what it's going to do is it's going to receive a string called, and it's going to have commas written inside of it, and it is going to print out individually all of these individual characters with commas in between all of them. All right, and then we can say print fn and commas and string, upper string, and we'll save that and we'll run it so you can see exactly how that works. And there you can see, went and printed out all of the individual characters separated by commas. Okay, neat stuff. Let's do some more stuff. Let's say that we want to check if any of the characters meet a condition. So let's say, for example, we want to check if any of the characters are uppercase. We'll go any upper, and this is going to be a Boolean, of course. It's going to receive a value of true or false. So we'll throw B inside of there. And then to do that, you go string dot exists, and then we'll go fun and C, little arrow symbol like that. And then we'll go character is upper, and there will be the individual characters that are pulled out from inside of the string we pass inside of it. And here, what we're going to do is, let's keep it simple. Let's just go string 1. See if any of the characters in string 1 are going to be uppercase or not. Oops, forgot to put the little percent sign in there. And we'll execute it, and we know the answer is going to come back as true. And yes, indeed, any upper, and you can see it comes back as true. Okay, so tons and tons and tons of examples. All right, let's do some more. Let's check if any character meets another condition. So what we're going to do is we're going to pass in a string that's going to contain digits, and we are going to check if any of them, or we're going to check if all of them, all the characters inside of the string meet the condition. So we're going to say print fn, and we'll go number, and basically we're checking to see if the string passed in is actually a number. And to do so, we go string for all. So every single one of them has to meet this condition. And we'll go fun C, put arrow inside of there. And then check if a string or if a character is a digit for every single one of these, we'll use isDigit. And we'll throw C inside of there. And then what we're going to pass inside of here is 1, 2, 3, 4 stored as a string. And we'll run it. And that's going to come back as true as well. And you can see that it does come back as true. So trying to do some useful things here while explaining a whole bunch of random things we can do with F#. Let's say we wanted to apply a function to each index in a string. So actually what we're going to do now is we are going to say that we want to pass in a value of 10 and have it automatically convert all of those numbers up until 10 to strings and print them out on the screen. So it sounds like something really hard to do, not with F#. So I'm going to call this string 1 and go equal to string init. We want to get 10 index values, and then we're going to go fun I this, and then I and to string. So there it is, and there it is, and there it is. Now, of course, we can print that out and see what that looks like. So this is just going to be a whole bunch of numbers. So numbers, and it's a string and string 1. Okay, and I'll do one final one. You can also apply a function to each item in a string. So let's go string dot iterate and function C and print fn and individual character C, and the string it's going to pass inside of here is print me. All right, so we have all those set up, all these cool things we can do with strings, and there you can see. It went and generated the values. It generated 10 values, 0 through 9, and printed them out on the screen as if they were strings. And here it cycled through the string print me and printed all of those out on individual lines because we used printfn. And remember, anytime we print an individual character with printfn, we are also going to get a new line at the end. Okay, so a whole bunch of things we can do with strings with F#. Now let's go take a look at looping. Now you are normally not going to use looping like you would in object-oriented languages with F#, but you can. So I just changed that to loop stuff. So why don't I show you what a while loop looks like inside of F#. So we'll go let, this is going to be a magic number guessing game. So I'm going to go magic num is going to be equal to, and I'm just going to have this be a string and 7 inside of it. Then I'm going to go let, and I want to be able to change this value, so I'm going to name it Mutable, and guess is equal to, and here this is just going to be an empty value. Now the while loop is going to go while not, and we will go magic and number equals, and then pass in the guess. We'll then do. So as long as the magic number is not going to be equal to the number they guessed, we're going to continue to do everything inside of this loop. So make sure we tab inside of here, and I'm going to go print f, and I'm going to say guess the number, and ask them to guess our number, of course. And then I'm going to go guess and change the value of guess, just like we did before, by reading in a value. So we'll go console and read line, exactly like that. And then after they do guess it, we're going to go print fn, and we'll say you guessed the number. And we'll put a space inside of there so it looks a little bit better. And there it is. Okay, so that's how we can create or use a while loop to make a little guessing game. So it says enter a number, and I go 1, and that's wrong, 2, 3, 4, and 7. And you can see there it worked. Okay, so example of while loops and how we can do cool things with while loops. And let's take a look at for loops, and then I'm going to show you how we normally do looping inside of F#. So for a for loop, we're going to go for I is equal to 1, 2, 10. Okay, so makes sense. We're going to loop from 1 to 10. And I'm going to show you a couple examples. Make sure you tab in. I'm going to go print fn, and I'm going to print out all of those values. Okay, let's do another for loop. Let's say we wanted to iterate downwards. We could. We can go I is equal to 10, and then we're going to go down to 1. So you're going to go from 10 to 1, and let's go and let's print that out. So there that is, and there that is. And as you can notice here, the i's are going to be contained inside of the for loop themselves. So that's how we can change the value over and over again. We're also going to be able to iterate over a range. So we're going to go for and I in, and then define your range. So 1 to 10, and then the do. And then after that, all the things you want to do. So we want to print all those values out. And why don't I show you the F# way of normally iterating things? Why, instead of doing all this, whenever we can actually pipe values, why would we do loops like this when we could just pass in a list into a function and have it just work? And I want to give you an example of that. So we can just go 1 to 10, exactly like that. And we're going to pipe it into, we're going to go that we want to iterate these guys. And what we want to do is we want to pass them in here and have them print the values over and over again. So num, and there it is, and there that is, and there this is, and there we go. And that's going to allow us to print that. Another thing we can do, just as our final example here, is let's say we want to be able to sum a list. We can just go let and sum is equal to, and then go list dot and reduce, and throw a plus inside of there. That's the operation we want to do, and we'll say 1, and let's do this to values 1 through 10. Add those all up. Do I still have a print in there? Yes, I do. And we'll call this sum like this, and then sum is going to be passed out on there. So real quick ways to do all kinds of cool things. And here you can see there's a whole bunch of different things. First we iterated through 1 through 10, and then we went and iterated from 10 to 1, and then we iterated from 1 to 10 once again. And here you can see that we were able to go through and output all of those guys using this handy dandy little thing here where we piped all those individual values from the list into here to print. And then you can see here we summed all those values. Okay, so neat stuff we can do with looping inside of F#. And now why don't I dive in here and get a little bit more into how conditionals work. So I'm going to call this conditional stuff. Let's just abbreviate that. And conditional stuff. All right. So let's go and take a closer look at if, else, and ELIF. So we're going to define an age, and it's going to be equal to 8. What we can do with if statements then is go if age is less than 5, then we want to print some information on the screen. And what we want to print here is, let's get rid of that. We'll go preschool. Okay, so that child is going to preschool. ELIF, same as else if, age is equal to 5. You can see you just have the regular equal sign there. Then we want to print something else. So in this situation, we will go kindergarten. All right, simple enough. And else if, let's do another one. And we can also put these on top of each other. We'll go age is greater than 5. And so both of these are going to have to come back as true if we're going to do what comes up next. And we're going to be able to go less than or equal to 18. Well, in that situation, then we're going to, well, let's go and do a calculation first before we do that. We're going to calculate the grade. So we're going to go let and grade equal to, oops, get rid of that, age minus 5. And then let's go and output that new piece of information. And that's going to be, whoops, put that there, go to grade, throw this inside of here, and then change this to grade. Okay, so we're able to stack those. And else we're going to say, this is the default, none of the others are true. We're going to say go to college. All right, and there we are. So there is an example of how we can use if and else and all those guys. And you can see since it was the age of 8, comes back with go to grade 3. All right, so neat stuff. Let's do another example. Why not? So I just want to show you some more things we can do conditional wise by demonstrating how the or logical operator works. Let's say we want to define who gets a grant, a college grant. So we're going to say that the person applying for the grant has a GPA of 3.9, and it's also based off of income. So we'll say income for said student is going to be equal to 15,000. And then what we want to do is we want to go print fn, and we'll say, whoops, college grant. Oh, by the way, did I mention comments? Just put, there you go, that's a comment. And this is a multi-line comment. So multi-line comment. All right, for some reason I forgot that. So that's how you do comments and multi-line comments. All right, so let's go. This is a Boolean. I'm just doing this stream of consciousness out of my head. So we will then go GPA greater than, whoops, or equal to 3.8, and or if their income is less than or equal to $12,000. In that situation, we will say that student qualifies for a grant if either this or this comes back as true. All right, and otherwise, the other logical operator available to you is going to be the not symbol. And how that works is, let's just go and give you an example. We'll go not true and Boolean, close that off. And then you go not and true. So not is going to turn trues into falses and falses into trues. It's very powerful. Let's run that. And you will see college grant. Yes, it comes back as true. And not true, well, it not turns trues into falses, and you can see it did that. All right, so conditional operators and how they work. Hey, let's do another one. Another thing that's kind of considered to be a conditional operator is match. All right, and you can use match and guard statements to do basically the same thing you just did up here. Let me give you an example. So let's go let grade 2 and string equal to, and then we're going to say match age with, and then we'll put in our different conditions. So we'll go pipe, or we'll put that symbol in there, and we'll say age when age is less than 5. Well, in that situation, we want to return preschool. All right, so there's that. In a situation in which we have a value of 5, in that situation, we want to return kindergarten. You do all kinds of neat things with match. And we're also going to be able to come in and go age when, and we can stack these up just like we did before. Age is greater than 5, and age is less than or equal to 18. Stack those up. In that situation, we want to do more. And what we want to do is go, whoops, age minus 5, and then we want to convert that into a string so we can output it on the screen, and we'll go to string to do that. Okay, and then we'll go in, and by default we'll put an underscore that represents by default, and in that situation this is going to return a string that just says college. All right, and let's go and run it. So print fn, and we will change this to grade 2 because that's what it is, and throw in that %, and this is going to be a string, of course. And then we'll change this to grade 2. And whoops, what did I do? Whoops. Okay, I've saved that. And let's run it and see what happens. And you can see it still comes back. Grade 2 comes back with a value of 3, just like the other one did. All right, so more stuff. And why don't we go and talk about lists? All right, so let's call this list stuff, just to stay consistent, and list stuff. All right, so what we're going to do first is we are going to create what is called a list literal. So I'm going to go list1 is equal to, and 1, and 2, and 3, and 4. Okay, you saw this before, but we're going to do cooler things here. Let's say we want to print the list. Let's go print, and let's just pipe it inside of there. Nice and easy. List, iterate, and we want to go print fn, and have each of these items come out on the screen on their own line. All right, you already sort of saw that. Whoops, change that to I, of course. All right, so we got that. We can also come in and print the items using the internal representation of a list with the A. So list1, and there that is. You're also going to be able to use the cons operator to join a whole bunch of different values. So we'll go 5, and 6, and 7, and that would be an empty list in that representation. And we can print that out just so you can see what that looks like. So print fn, and we'll do something like that, and list 2 in that situation. Like I said before, we're going to be able to use ranges. So we can go and call this guy list 3 just to stay consistent. Say we want values from 1 to 5 in the list. Well, there you go. You just created that. And you can also create ranges with letters inside of them. So we can go list 4 equal to, and let's say we wanted to get A through G. There you go. That's how easy that is. Now you have a list with letters inside of it. And let's go and print out list 4 in that situation, because that's the one that's a little bit more interesting. And you've seen ranges before. You're also going to be able to generate a list with a init, like we saw before. So let's say we want to create 5 indexes and multiply those indexes times 2. We can do so. So we'll call this list 5 is equal to list and init. It's going to create 5 indexes inside of there, and each of those indexes it is going to multiply times 2. So we'll just go I times 2, and there that is, and we'll print out that. Let's go like this, and let's run it and see how it works. All right, here you can see. So we got 1, 2, 3, 4. There we were basically, let's go up here. See, 1, 2, 3, 4. This is how we were generating those guys right there. And then you can see here where this is the internal representation of these values. We used a range here. We used another range there. And then down here, you can see that we generated 5 values and then multiplied each of those index values times 2. So 0 times 2 is equal to 0. 2 times 2 is equal to, well, 1 times 2 is equal to 2. 4, 6, and 8. All right, and we're going to do more. So let's keep on going. Keep everything here on this page. Let's say we want to generate a list using what we call yield. What this is going to do is it is going to, in this situation, going to multiply each of the index values times themselves. We can do that. Let's call this list 7. Whoops, now let's call it list 6 equal to, and then we'll go A in, and let's say we want to go 1 to 5. Do and yield and multiply A times A, and we can generate that guy. And let's do another one. Let's go list 7 equal to, and here we're going to generate an even list. So we'll go 4A in 1 to 20, do, and then we'll throw a condition in here. So we'll go A, and this is the modulus, is equal to 0, then yield A. So if that condition is met, then yield it. And another thing we can do is we can use something called a yield bang. And what it does is it creates multiple lists for each item and then merges them into a final list. So I'm going to show you an example. It's kind of crazy stuff. So we'll go list 8 is equal to 4A in 1 through 3, and we'll go do yield bang, which is going to be the exclamation mark, and then we're going to go a dot a plus 2 like that. And what it's going to do is, let's say you pass in 1, 2, 3. What it's going to do for the 1 is actually go and generate another list, which is going to be 1, 2, and 3. So it's going to go through, and the first part of the list is going to be whatever you pass in. That's where the 1 is. And then the next one is going to be a plus 1. So that's where the 2 is. And then a plus 3, or a plus 2. I'm going to show you an example, and then it will make sense. And why don't we go and print all these guys out as well. So neat stuff. So 6, and then this one is 7, and then we will print out 8 as well. So there's list 8. And let's run it just to show you an example of cool stuff we can do. And here you can see, well, let's come down here. Here we generated 1 through 5 and multiplied them times themselves. So here we got 1 times itself is 1, 2 times 2 is 4, 3 times 9, da 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 da. And then down here we went 1 through 20, and we said we only wanted even numbers. We can see we generated only even numbers. And here we went and yielded, or used the yield bang, which is going to take 1, 2, and 3, and then perform these operations in this range on those things. So you can see this is for the 1, this is for the 2, and this is for the 3. All right, so cool stuff. Let's do some more. Functional languages love lists, so of course there's a lot of things you can do with them. Let's say we wanted to get the length of a list. Let's just go in here and go length, and of course that's an integer. And let's get list 8 length. We can just type in length, and that's going to get it for us. We can also check if a list is empty or not. So we'll go in and we'll change this, we'll change this to empty. And of course that's going to be a Boolean value. And we'll do this on list 8 as well. So list 8, and you go is empty, and it's going to give you an answer for that. And we can also get an item at a specific index. So let's say we wanted to get something like what is at index 2, and we're going to use list 4 for this, which is a whole bunch of characters. So we'll go like this, and we'll go list 4 and item, and to get index 2, you just put index 2 inside of there. If you want to get the very first item, that is often referred to in lists as the head, we can do that, and we'll do the same thing for list 4, just so you know. Our list 4 is this guy. Where is list 4? There it is. See, it generated a whole bunch of letters inside of there, so we're going to do this for list 4 once again, and we'll get the first value. So we'll go list 4 and follow that up with head, and now we got that. We can also do the tail, which is everything except for the first item. So we'll go use the A in that situation there, and we'll go list 4, and of course we put tail inside of there, and that gives us a tail. We're also going to be able to filter out, let's say for example we want to only do evens. We can do that. Let's go let list 9 equal to list 3, and we're going to pipe this in to list filter, and then put our condition inside of here. So function x is equal to that, and then we'll do the modulus of 2 is equal to 0. And of course I'm just using the modulus a lot and generating even numbers because I think it's easy to understand. Let's say we want to multiply all values times themselves. Let's go and create another list, and this will be list 10 is equal to, and we're going to go list 9, and we're going to go list, and we'll use map, and then define the function we want to perform on each one of those items. So like this, and that's going to be x times x, multiply those values times themselves. And what else can we do? Well, final thing we can do is we could sort a list. So let's go and sort it. So we'll call this sorted, and we'll just get the internal representation of that, and we will go to list and sort, and let's just do one we generated here. We'll do everything backwards, so 4 and 3, and we'll see exactly how that prints. And as the final thing here, there's so many things to do. Oh, this is supposed to be list 9. Don't want to mess that up. Okay, got that fixed. And the final thing I want to do is show you how to sum a list. Showed you it before. Show you another different way of doing it. We can go sum and I, that's going to be that value. And we can go list and fold. And then we can go and call this function sum. And you're going to get an element passed inside of it. And then you're going to go sum plus elements. And we will throw 0 inside of there. That's going to represent the sum value right there. The sum obviously starts off as 0. And then we will have our list inside of here. So 1, 2, and 3. And then we will close that off and close that off. And of course we could have a name of a list inside of there. And let's run it. And there's a build error. What's a build error? This value is not a function cannot be applied. 35. What are we doing here? Oh, it just got confused. I bet you because of the space it's not there. There we are, got rid of it. Let's run it again. And here we go. And there you can see. There is the head, there is the tail. This is whenever we got the index. This is whenever we checked if it was empty or not. Here we start off with 5, 4, 3, and it sorted them. And here it went and summed those values. All right, so whole ton of things to do with lists. You should go in there and experiment with them. And now I want to talk about enums. Now, basically enums, let's change this to enum stuff and this to enum stuff. Enums are going to allow us to use sort of flowery specific information and assign names to our data to make it make a little bit more sense. So we're going to do this outside of the function. We're going to go type and emotion equal to, and then we define all of them. So we can say an emotion would be equal to joy and give that a value of, well, let's make it 0. And then we have fear, which is going to be equal to 1. And then let's define a final one, which is going to be anger, and give that a value of 2. All right, now let's work with it. So let's go and create it. And let's go my feeling is equal to, and then you go emotion followed by joy. Okay, and then what we can do is let's say we wanted to do a match, just because I really like matches. All right, so we'll go, if my feeling matches whichever one of these guys, we're going to perform different operations. So if it's equal to joy, what we're going to do is we are going to print out some information that is going to say something like, I'm joyful. Okay, joyful, like that. And then we could come down here, and if the value is equal to fear, we could print out, I'm fearful. Okay, so I'm fearful. Whoops, there it is. And let's do another one. Let's say anger, and and then we'll say I'm angry. So I'm angry. Why is it not angryful? All right, and there's an example of just the different things that you can do. All right, so now what I want to do is talk about options. Call this option stuff and change this down here to option stuff and then back up here. Now basically an option is used when a function may not return a value. So let's give an example here. Let's do a division in which we want to block a situation in which they could pass in a 0. So a division by 0 error. How we do that is let's go call this guy divide, and let's say it gets x and y as a value, and then we want to use match, and we're going to say with, and then we're going to have our different values. So if they pass in a 0, what we want to do is return none. Otherwise, by default, everything else is going to be fine. So we are going to say sum, and then we'll go x divided by y, like that. Then what we can do is we can come down here and say if, and divide 5, 0, and there it is, and we'll say is sum. Then we want to go and print out some information. So we'll go print, and even though we know this is never going to work, we're going to go 5 divided by 0 is going to be equal to, and there's the a, and then after that we're going to call the divide function. So we'll go divide 5 and 0, and if we want to get the value from that guy, we can do so just by putting value inside of there, and then we can go ELIF and divide and pass in 5, 0, and put that there. And here we're going to check if it is none. That returns value of none. Then we're going to go then print f like this, and we'll say can't divide by 0, can't divide by 0. And then we could also come in and go else, and we can just say something happened, we don't know what. So we'll go print fn, whoops, what am I doing? We could say something happened. So something happened, and there that is. And if we run it, you're going to see can't divide by 0 goes in there. And the reason why is we passed in a 0 inside of there. So you can see exactly how all of those different guys work, and that's an example of options. And now we're going to talk about tuples. Okay, so basically a tuple is a comma-separated list of values of any type. So let's go and let's create one. So we'll go let average. We're going to create a function here, and it is going to receive x, y, and let's go w, x, y, and z. And it's going to receive or return a float value. And then inside of our function, we're going to go let, and sum is equal to w plus x plus y plus z. And then we're going to go and get the sum and divide it by 4.0. All right, so good. And then we're going to go and print out this information. So we're going to say average, and this is going to return a float, of course. And then we're going to call our new average function. And we're going to do so by passing it a tuple. So we'll go 1.0 and 2.0 and 3.0 and 4.0. All right, so there those is. And why don't I go do another example here? I just want to briefly touch on tuples. We can also, like I said, store multiple different values inside of here. So we can say Derek, for example, and 42 and 6.25. So there's a whole bunch of different data types. And if you want to get data from a tuple, let's go let and name. We're actually going to assign multiple different values inside of here. And let's say we don't care about the height. So we're just going to put that inside of there for the data we don't care about. And we're going to receive all that information. This is my data. We're going to pull out Derek, put it in the name variable, pull out the age, put it on there, and then say we don't care about height. And then we're going to print out some information. And what we're going to print out is name. And that's a string, obviously. And to get that specific thing, we just go name. All right, got that set. Let's run it. And you can see it was able to calculate the average, and it was also able to pull my name out of the tuple. Okay, so some brief stuff on tuples. Now I want to talk about records. Okay, so basically a record's just going to be a list of key value pairs for creating custom types. We're going to create one outside of our function called customer, and it's going to have some data inside of it. And let's make sure we put the white space inside of there. So I'm going to say the name's going to be the key, and it's going to contain a string and whoops, semicolon. And then we're going to have the balance that the customer owes us, and that's going to be a float. All right, so you just created a custom record. Now inside of our function, we're going to create one. So we'll go let Bob equal to, and then inside of here, we're going to define all that stuff. So we're going to go name is equal to Bob Smith, and close that off, semicolon, and his balance is going to be equal to $101.50. So Bob Smith owes us some money. And if you want to get some information out of there about what Bob Smith owes us, we could go and get the string, which is the name, and go owes us. And then we can go and get the float, cut it down to just 2 digits. And then we can just go Bob and get his name out of there, and then Bob, and then get his balance out of there. All right, whoops, spell balance right, and there it is, and let's run it, and you'll see that that works. All right, and Bob Smith owes us $100.50. Okay, again, brief explanation, just wanted to just briefly touch on records, and now I want to get into a pretty cool example of how we can use sequences. Okay, now sequences are going to allow us to create what are called infinite data structures that aren't going to be defined or populated until they are needed. So let's come in here and let's say, let's just generate a sequence of 100 values. So how you would do so is you go let, and let's call this sequence 1 equal to, and then you go sequence, and I'm going to show you exactly how they work. So I'm going to go like that, and then 100. Whoop, 1000. I don't care. It could be 100 or 1000. All right, and let's generate another one. Let's go and create another sequence. And let's call this sequence 2 equal to sequence. And here, what we're going to do is we're going to generate even numbers. So we'll go to do so. We go 0, dot, dot, 2, and that's going to define how we are going to increment. Whoops, make sure that's 0, and then go dot, dot, 2, and then dot, dot, and 50. All right, so that's going to generate only even numbers from 1 to 50. So that's where you define how much you increment each time through. And let's do another one. We could do a descending sequence. So we'll go sequence 3 is equal to, and I'm also showing you how to do things with ranges here, but whatever. It's nice to learn multiple things at once. Put that there. This sort of bothers me. Let's make it right. Okay, there we go. And what you're going to see here is if we try to print any of these, they're going to be abbreviated. So what I mean by that is we'll go and try to print sequence 2. We know that that's 50 digits, or no, 25 digits. Let's run it. And you can see whenever I print it, it only prints out the first 4. Okay, so the sequence isn't going to be generated until it is actually required. Now, you could actually come in and print the whole list, however. So let's go, and I'll show you how to do that. What you do is you go sequence and 2 and convert it to a list. And then you go sequence and 2, and we're going to use our pipe here once again, and list and iterate, and then say what we want to do with that information. So we'll go printfn, and we'll print all this information on individual lines. So like that, and like that, and like that. And what that's going to do is allow us to print the whole list. Force it to. All right, see? Printed it all out there. And otherwise, it's not going to. So what we can do now, let's do something really cool. Let's say we want to generate a whole bunch of prime numbers. What I want to do here is create a function that's going to test if a number is prime. So I'm going to call this is prime and receives a value, and it's going to test if it's prime. I'm not going to get into the math. This is a recursive function, so it's going to come in here and generate or check multiple different values that are passed inside of it. So I'm going to go I is greater than, and we only have to check up to half the value to find out if it is prime or not. And then we're going to also come in here, modulus I, and and we'll go and check once again, and I plus 1. I just want to keep this, I want to do something cool, but I don't want to explain all that. All right, so if you guys really want to know, I'll explain how the prime numbers are generated, but that's a general, very easy way to generate if a prime number is prime or not, or if a number is prime or not. So what I'm going to do here is if is prime returns true, then I want to add it to my sequence. And if not, it won't be added. So I'm going to go let and prime and sequence is equal to sequence. And then what we can do is go for and in, and let's say we want to get 100. We want to check 500 digits. Okay, so we can do that if, and then we'll go is prime and then yield. That means it's going to go into my sequence. And then after that, what I can do is I can go and print out all those prime values. So I'm going to go prime and sequence. And we're going to run this guy. As long as I did everything right, looks like I did. And there you can see it went and printed out the abbreviated version of that sequence. So let's go and say we want to print out everything. Well, we're going to do it in pretty much the same way that we did before. Let's go and just copy it. Get that, throw that there, and then we'll go sequence to list, and we'll change this to prime sequence. Prime sequence, list iterate, Let's change this to prime, and then this is all cool. We can leave that exactly the way it is, and here we can actually have it generate all those prime values. And you can see it printed out all the prime values from 1 to 500. All right, neat. Okay, so there's a whole bunch of examples of sequences and how you can set them up and how they work. And now I want to talk about maps. Okay, so of course I changed that to map stuff. Now basically maps are collections also of key valued pairs. And let's go and create a map. So what we need to do, I'm going to create a map called customers. And very first thing you do whenever you create a map is you generate an empty map. So you go map empty, and then after you're done with that, you're going to add your key values to your map by using add. So I'm going to add, and I'm going to go Bob Smith, and then I'm going to say Bob Smith owes us, whoops, make sure you put quotes around there. We're going to say Bob Smith owes us $100.50, and then you follow that up with a period. Let's add another person. So we'll say we want Sally Marks, and there's Sally Marks, and she owes us $50.25. I'm really obsessing about this, and there you go. So you just created yourself a map. Now let's go in here, and let's say we want to find out, whoops, don't want that, printf-n, and I'll say number of customers. Let's say we want to get to the number of customers in our map, like that. What we do is just go customers and count, and that's going to get that for us. I'm going to do a whole bunch of other things here though first. Let's go get that, and let's say we want to find out what Bob Smith's balance is. I'm going to go let and customer equal to customers. I'm going to go try to find Bob Smith in the list. And then how I do that is go Bob Smith is the key that I'm searching for inside of here. Now what I'm going to do is I'm going to use match to define what happens. So I'm going to say match customer with, and then if we come back with some value, X, well, in that situation, we know that we received a Bob Smith match, so we are going to print some information out. We're going to say that we want to get the balance for Bob Smith or whoever else we're searching for. So we'll go balance, and then we want to go 0.2f just to abbreviate that, and then we'll get the value of X. And otherwise, if there was no match for Bob Smith, we will do something else. We will say not found. All right, just to keep that simple. So we're not found. All right, so we got that. Let's do some more stuff before we start printing things out. Let's say we want to list our customer names and balances. Pretty easy. Let's go customers, customers, and at A, and then pass customers inside of there. So customers. Let's say we want to test if a key exists or not. Go customers. And we go contains key, and then we'll pass in Bob Smith. Bob Smith. Well, if it does contain Bob Smith, well, then we have to define what we want to do. In that situation, we will say something simple like Bob Smith was found. And you can also come in here. Whoops, don't do that. Let's go and put that back where it goes. All right, let's do another thing here. Let's say we want to get a value of a key. So we'll go like this and put that over there, and we'll say Bob's balance, like that, and we'll say like this and like that, and we'll say customers and Bob Smith. So put the key inside of there, and there that is. And then finally we can remove items. So we'll go let, and let's create a brand new customers item in here, and we can go map and remove, and we'll say we want to remove the key for Sally Marks from the customers, and then we can come in here and print it out to show that it works. So we'll say number of customers, and we'll go cus2 and count just to prove that it all worked. All right, let's run it and let's see what we got. And there we can see. Started off with 2 customers. Now we have 1 because we got rid of Sally Marks. You can see here if we wanted to print out the balance, we found Bob Smith, and we also were able to print out Bob Smith's balance. All right, so cool stuff that we can do with maps. Now I want to briefly talk about generics. All right, so generics, let's do an example here. Basically, a generic is going to allow you to use any data type in a function. So let's go and define 2 functions. I'm going to have one be add stuff, and how you define, you don't know what's going to be coming in here, is you go single quote like that, and t and then x and y is equal to, and then what this guy's going to do is it's going to print out this addition. So I'm just going to keep it simple, a, and inside of here we'll go x plus y. We do it that way, of course, because we don't know what the data type is. And now what we're going to be able to do is come in here and call add stuff and define that we are working with floats in this situation, and go 5.5 and 2.4, something like that, and it will work. So let's run it, and you can see 7.9 comes back, and then we could also come in here and we could do ints, and we'll do this a little 5 and 2 or something, and there you are, and there's a generic. All right, run it. Whoop, went down here, and there's 7. All right, so there you go. Very, very brief explanation of generics. Now we're going to talk about exception handling. Call this exception stuff, or EXP. And of course, exception handling is going to allow us, or provide us with a way to catch errors. So inside of here, let's go and let's do our divide example again to catch the potential division by error or division by 0 error. And what you're going to do, just like many languages, is you're going to say try, and then we are going to go and try to do this. So we're going to do something like 2f and divided by 0.2f is equal to, and 0.2f, and then have x and y, and then x divided by y inside of there. Now, then we're going to put width inside of here like we normally do, and question mark, and we're going to say that we expect it is possible to have a divide by 0 exception. So divide by 0 exception, and in that situation in which we do, we're going to go like this and print a message that says can't divide by 0. And that's going to keep the whole program from crashing, and instead it's going to print out can't divide by 0. All right, so we got that set up. Now let's go and try to do it. Let's try to break it. So we'll go divide, and we will pass in a 5.0 and a 4.0 like this, and that's perfectly valid. And if we run it, you're going to see that it goes and it does it, no problem at all. However, if I would come in here and go try to pass a 0 inside of there, and if we run it, you're going to see that comes back as infinity. Why? Because the exception wasn't actually called on that. It considered it to be okay. Well, not just so I don't have to mess around with casting and so forth. I'm just going to change that to 5 and 0, and then change this to I. And then we're going to raise our own exception. So let's throw this inside of there. Okay, and now those are all going to be integers, so we don't have to worry about that. And now you can see what I did was I threw in an if statement. And what it's saying is if y is equal to 0, then I want to raise an exception, and this is the message that I want passed to it. Otherwise, I'm going to say everything's okay and just perform that calculation. And you can see down here, it is going to work this time. So let's run it. So that's how you raise exceptions, catch exceptions, and so forth and so on. So yes, exception handling requires more diligent coverage, but like I said, I'm trying to cover everything as quickly as possible. And now I'm going to talk about structs. Okay, so structs are going to allow us to create our own data types. So what I want to do is I want to create one called a rectangle, and you have to define that this is a struct, and then inside of it you're going to define some different values. So I'm going to say my rectangle is going to have length, and that's going to be a float, and then it's also going to have a width, also going to be a float. And then I need to define what happens whenever I create one of these data types. So I'm going to say that length and width is passed inside of it. And whoops, make sure that's an equal sign. And whenever that occurs, what I want to do is assign length to whatever the length was that was passed inside of it, and width is going to be whatever the width was that was passed inside of it. And then finally, after we do all of that stuff, we're going to put end inside of there. All right. Whoops, got an error because I didn't put a semicolon. All right, and that fixed it. All right, so then let's go down here and use our struct. So I am going to say let area. I'm going to create a function, and it's going to receive, or I'm going to call it shape, and it's going to be of type rectangle, like we just defined here. So rectangle, there that is. And whenever this guy's called, it's going to take the shape, and it's going to get the length and multiply it times the width. So there that is, and there is how we work with our custom data type. So let's go create a rectangle is equal to new rectangle, And let's say we get a 5 and a 6 passed inside of there. And now let's go and get the rectangle area. So we'll go rectangle or rect area. Throw that inside of there, put this here, and call our area function, pass in the rectangle we just created, and then let's go and print out our results. So we're gonna say area, and like this, and then whatever the rect area value is. And why is that giving me an error? Oh, because I forgot to put the equal sign in there. All right, so we save that, and let's run it, and you'll see how it works. And there we calculated the area. All right, so again, brief explanation of structs. And now I'm going to finish off the whole tutorial by talking about classes as well as inheritance. All right, change that to class stuff. Let's come up here and define a class. Now, a class is just going to model a real-world objects by defining the attributes called fields and the capabilities called methods of those real-world objects. So let's just do a simple one. Let's call this animal, and we have to define that it is going to be a class, and then we're going to define the attributes or fields. And so we're going to have this, which is going to be a string, and there's also going to be a height, and that's going to be a float, and another value we'll have is a weight, which is also going to be a float. Now we need to define our constructor inside of here. How you do that is you go new, and then all the things that get passed in every single time you create a animal object. So we'll go height, name, height, and weight. And whenever that is called, we are going to, let's go down here. There we go. And we will define everything. So we'll say name is equal to whatever the name was they passed in, and make sure you use semicolons here. And height is going to be equal to whatever the height was that they passed inside of here, another semicolon. And then finally, weight is going to be equal to whatever weight they passed inside of here. Close off with the curly brackets. And then we can now define the capabilities or methods. How you do that is you go member and X, and let's say we want to define run as a function our animal is going to be able to do. We can do so by going print like this, and then we're just going to keep it simple. We're going to say whatever the animal's name is, and then followed with the word run. And then how you get that animal's name is just by calling X and name. After you complete all of that stuff, then you have to put end inside of here. So what I'm going to do right now is I am going to, hey, you know what? I might as well come in here and show you inheritance. So through inheritance, whenever you create a class that inherits from another class, it is going to receive all of these attributes and or fields and methods that are in the animal class. So I'm going to create another one. I'm going to go dog. This is going to be a dog class, and we're going to define name and height and weight, and the constructor inside of animal is going to take care of all that for us. So we go equal, and then we're going to say what we're going to inherit from. So we're going to inherit from animal, and whenever we do, we are going to pass it the name and the height and the weight, so that the constructor in animal is going to be able to handle all that and initialize my dog objects as well as animal objects. And then we can come in, and not only do we get all the fields and methods, but we can also create our own. So we can say member, and let's say we want to have our dogs be able to bark. Well, now they can, and we'll do this, and we'll do that, and we will here say whatever the animal's name is, barks. There that goes, and then to get the name, we do exactly the same as we did before. And now we can test out this in our class stuff function down here. So class stuff, and let's go and create Spot. And he is an animal object, and his name is Spot, obviously, and he has a height of 20.5 whatevers and a weight of 40.5 whatevers. There you go. And we can go Spot and run, and Spot's going to be able to demonstrate how he runs. And now we'll create a dog object. So we're going to call this Bowser is equal to new dog and Bowser, and we'll say that this is the exact same size. So 25 and 45. There that is. And now we can demonstrate that the subclasses are going to be able to use not only the fields, but the methods and all that other stuff. So we'll go Bowser, and we'll call run, and then Bowser, and have Bowser bark. I'll put that on a separate line, obviously. All right, and we will save it, and we will run it, and you can see Spot runs and Bowser both runs as well as barks. So there you go, guys. That is an insane amount of information about how you can do so many different crazy cool things with F#. Hope you guys enjoyed that tutorial. If you did, please leave a like. I mean, this is crazy. So, just like always, please leave your questions and comments below. Otherwise, till next time.